All right, hello everybody. Good afternoon. My name is Jared Sheehan. I'm going to go ahead and kick this off because it's 1:30. It's a good time to go. First of all, the talk is about speech recognition or voice recognition. And I wanted to ask a quick question. How many people in here have actually used speech recognition in the last week? Man, that's it? Come on, guys. How about the last year? All right, very good, awesome, very cool. So speech recognition and voice recognition and dictation and things like ASR are very, very powerful tools, especially for mobile. They kind of bridge the gap between mobile, web, and really the ability to execute actions much more quickly for customers. You don't have to worry about necessarily clicking on something else to eventually send a text message, right? You can basically enter speech and just have it work for you. So I'm going to show you a couple of ways that is being used in industry. I'm going to go ahead and get started. But first of all, my name is Jared. I work for a company called Diversity. I'll probably talk a little bit more about that in a few minutes. I do have two of my teammates in the audience, Ray and Raj. All right. So just give you a little background on myself. Let's see, right now I'm, kind of high level. I'm a glass explorer, speech recognition enthusiast. I'm a big Android nerd, that's for sure. Right now I work for Diversity. We are solving driver safety for the mobile generation. I was previous to Diversity, I worked for Amazon. I helped build the Amazon speech recognition system on the Fire Phone. That was a whole lot of fun, let me tell you. I also previously worked here at AOL in this building with a few people, lady right there as well, on a lot of different applications, AIM and Gadget Distro, TechCrunch, that kind of thing. I've been doing Android development since 2010, so I've got a decent amount of experience with Android. Also, I'm a bit of a meetup evangelist. I really, really love meetups. I love things like DevFest. My cohort, Nate over here, we are co-founding the DC Android Meetup Group. Please go sign up. We are going to do lots and lots of very techie, code, designy type of meetups. We're going to try to have lots and lots of really good content. And I'm all about hackathons, let me tell you. All right. Next, a little overview of what I'm going to talk about. I'm going to talk kind of high level of what voice and speech recognition really is. I'm not going to get too deep into things like Markov or hidden Markov models or anything like that, but I am going to briefly talk about it. Then I'm going to talk a little bit more, like I said, how it works, kind of the awesome stuff you can do with it. I'm going to show code. I'm going to show an actual demo of non-production code in our application. And then hopefully we'll have a Q&A. All right, so I'm going to show a quick little video. Everybody love Star Trek? Yes, definitely.
Please.
Computer? Computer? Ah. Hello, computer.
Just use the keyboard.
The keyboard. How quaint.
Sorry, I love that clip. Should probably go back to presentation mode. All right, so what is speech recognition? High level, basically what it means is you take translated or words that are translated into actual text. All of the words that I'm saying right now could be run through a speech recognition engine, and then the text could come out, including with words, punctuation, and full sentence structure. Computers can do that right now. And there are lots of cool things we could do, and that's really step one to the really cool things that speech recognition can do. All right, so like I said, what can you do with speech recognition? Like I said, it allows you to speak into software systems. You can speak to almost any platform. This is very ubiquitous across mobile, tablets, and other devices. The really big thing is what I alluded to earlier, is that you can replace standard user input of clicking, swiping, selecting, typing into a single utterance or multiple utterances with multiple turns. It makes your interaction with software and devices much more user-friendly. It is also used extensively through accessibility assistance. All right. ASR, what is it? ASR is, like I said, the first step in speech recognition. It's dictation, free-form dictation. It's the first step of understanding an actual audio utterance and translating that into some kind of text text that you can then do things with it. The idea is that you have audio goes through the microphone, streams somewhere, you get a result. Usually there's a confidence level. A lot of times you get multiple confidence levels. And a little plug for Android, speech recognition dictation is very easy in Android. Literally you can do it in like an hour, worst case, and that's with debugging. Well, there's two parts. There's two different ways. One's a lot easier than the other. All right, so how does it work? Basically, you have to have a recording device of some sort, microphone. You record the audio from the microphone. You'll usually encode it to a file somewhere, and then from whatever your client is, you will then stream it to your backend. The backend will then do a lot of really cool things like dynamic time warping, hidden Markov models, or neural networks to achieve the types of things you want. The previous bullet actually talks about things like phonemes, groups of phonemes, and words. What that means is that each word has different kind of subsections. So for example, the word to, T-O-O, the word T-W-O, and the word T-O, to, T-O, they may all sound very similar to like you and me, but computers are sensitive enough to really be able to understand the differences and inflections of those words. And so to do that, they actually have to break each part of the audio utterance down to be able to determine the difference between those words. Yes, there are very basic versions of speech recognition, and then there are much more advanced versions. So contextual awareness is part of how you get to do the really cool stuff. And I'll get to that. All right, so I was going to kind of do my own system architecture for this, but I found this online, so I'm going to and it's mostly right, so I'll kind of talk through this, but really quickly. The idea is that you have the voice input, but actually it's usually through the application probably. Then it'll go through some signal processing, decoding. This is basically where all your algorithms run, and then there will be a response back to the application. So that's very basic free-form dictation in kind of an architecture diagram. All right, cool. So into the weeds. There are different kinds of speech recognition. There's speaker dependent, speaker independence. Independence is more along the lines of anyone that speaks English, we ought to be able to support. Speaker dependent is much more narrow. Those systems are usually cheaper. Probably not used very much anymore, I would assume. But speech recognition has been around for decades. People have been trying to get this type of thing to work for a very long time, since the 60s, especially in computers. For example, Nuance actually licensed, I believe it was IBM's speech recognition system back in like the 70s to actually start all the dragon dictation stuff, and then they built their own. So then there's isolated word, continuous speech. Isolated word, again, is probably not used very often. It's usually you speak a word and then you pause, speak another word and pause. Continuous speech is continuous speech. So little bullet point at the bottom, how good is your system? The industry standard on measuring speech recognition is something called word error rate. And what it does is it takes truth text and an audio utterance, runs it through your system, and then you get a response back. And then you basically compare the truth text to the utterance, to the text that is returned. And then a word error rate is calculated. A good word error rate is probably 15, 16%. I don't know how many of you were watching Google I/O this year, but Google said that they dropped their word error rate by 3% in 1 year. That is amazing. Plus, they already had the best SR system out there. Debatable, but I think so. All right. But is that all it does, right? I mean, dictation is cool, but how cool is it? Right. The next step is what the gentleman alluded to here, is really understanding what a user wants to do, right? I can't skip all of those steps to go and send a text message unless I understand what the user wants. So the first step is actually getting what the user said, which is the ASR, automatic speech recognition and dictation. The second part is understanding what they want to do. Then you want to act on it. So ASR, usually how it works, the architecture is you have an ASR engine, and it puts out the results with a confidence level. Then that is then taken and put into something called an intent recognition system. The intent recognition tries to understand the intent of the user based on what it was that they said. So we take all sorts of contextual information. So if you're on a mobile device, what's your location? Are you on a computer? All sorts of different things. Basically, anything that could help give a hint to the intent recognition system to be able to determine what the user wanted, right? A good example of this is for making a phone call. If you say, I want to call Nate, what will have happened beforehand usually is that the speech recognition system will have uploaded all of your contacts and all of your contacts information and their phone numbers to the back end. And then when they see a keyword like I want to make a phone call, then they assume you want to call one of your contacts, and they do comparisons to that. So it's basically a vocabulary that they disambiguate from the contacts that are uploaded. And then, of course, last bullet is exactly what I just said. All right, so intent recognition. It's how Google Now knows that I want to send a text message, or Siri knows, how tall Kobe Bryant is, or, what Apple stock is. 3 systems. So I talked about ASR, I talked about intent recognition. So the intent recognition outputs what the user wanted to do, but then what happens? And the next step is a dialogue engine. The dialogue engine is what actually sends actions back to the platform, computer or mobile device, to then execute, basically what the user wanted to happen. So if I say call Nate, well, that's not enough because Nate may have 2 phone numbers. So the dialogue engine comes back and says, I know this is what the user wanted, but I need to show something to get more information. Okay, so you want to call Nate. Well, he has 2 phone numbers. Here they are. Which one? Mobile or home? That kind of thing. All right, next. So Android Speech APIs, I talked a little bit about them. This is it. It's not very big. It's pretty straightforward, and it works great. The 2 different types are the recognizer intent, which you see right here, and the speech recognizer down here. The 2 major differences between those 2 APIs are that the recognizer intent, how many Android developers in here? Okay. So you create an intent, which for all intent and purposes is actually a message to the system, right? It's very easy. Just send it to the system, and the system does something on it. That's literally all you do with recognizer intent. You can add some parameters, but you just fire it off. You don't have to build a UI, and the system just handles it for you. Speech recognizer class down there at the bottom is more of a service level. You will get the same speech recognition engine to work for you, but there are several callbacks that you handle, so it can provide a much better experience, right? So there's a built-in UI with the recognizer intent, and the speech recognizer actually can build a better user experience for dictation. And keyboards, for the most part, if there's like a little microphone button in your keyboard and you click it, then that's usually the type of intent or ASR speech recognizer that you're dealing with. All right. So I talked mostly about this. You need 1 permission. It's called record audio. You have UI and no UI. And then input method services for Android developers. That's basically a keyboard. And that's the no UI version. All right, so this is what a really old recognizer intent UI would look like. This is probably gingerbread. I don't know why I grabbed an old picture, but that's it. Anyway, you basically created an intent, you fire it, and you just wait for the results. It's very simple. Speech recognizer is a little bit different, right? So, what will happen is that the UI will pop up. This is a icon that's supplied by whatever keyboard this is, and then usually you can see some kind of waveform. There are callbacks, and I'll show those in a few minutes, that return a value called RMS, which is root mean squared is basically what RMS stands for. And it more or less shows the amplitude of the audio input from whichever user is speaking. So you can do really cool visualizations from that, and you don't have to worry about implementing that yourself. It's actually really cool. All right, so onto intent recognition systems. A few slides where we just kind of show some pretty standard ones. Google Now, I'm sure you guys have all, or most of you have heard of Google Now. I don't know how many of you used it. Then there's something really, really cool called Google on Tap, and I'm actually going to come back to this in a second. Apple has all of their Siri, has Siri, and they just released Apple. What is the Apple TV that actually has a microphone built into their remote, which is actually really cool. So Siri is Apple's intent recognition offering. And then, of course, I work for Amazon, so I have to show Amazon's speech recognition systems. And I'll tell you what, Amazon is selling out on this. They're putting this in almost everything. So Apple came out with their Apple TV that has a microphone in their remote control. Well, this came out about a year and a half ago, right? And all you have to do is just pick up the microphone and say, I want to see movies that have James Bond in it, and you get them all listed immediately. The Amazon Echo, I don't know how many of you have heard of the Echo, but basically you can walk into your room and say, I want to hear music from so-and-so, and it just starts playing music. So Microsoft has one too. It's called Cortana. All right, so speech providers, we can come back. So here we go. Google Now on tap. So who saw this announced at Google I/O? Anybody? All right. This is really friggin' cool. Basically what's going on is that Google Now can figure out which app is actually on screen, and you can ask questions to Google Now about that particular app. So if you have a music app and you're not sure who the artist is, you can ask Google Now and say, who's the artist that plays this? And Google figures out what's on your screen. That's the contextual information that the gentleman alluded to, and then it'll go give an answer to you. That is so powerful. And it's not just Google properties. If you look right there, this is from the Google Now on tap. Actually, no, it's an article from The Verge, but it actually says right here, Google to help by saying, okay, Google, from any screen and any app. That is friggin' cool, not gonna lie. That's awesome. All right, let's move a little forward. All right, so I talked about kind of the front ends of the speech recognition systems, Google Now, Siri, that kind of stuff. These are the actual speech providers, kind of the big ones. Microsoft, of course, has their own. Google has their own as well. The two on the bottom have been around for a long time. IBM Watson. IBM has a lot of speech recognition research and development that has gone into their products. And they do have an SDK for it, though I'm not as familiar with theirs as I am with Nuance's. Nuance has probably been around for 30-ish years, and they've been around doing a lot of speech recognition as well. All right, Google Voice Interaction API. So wanted to briefly highlight this. So there are standard APIs within Android to be able to use ASR, right? And we went a little bit over that, and I'm going to show those in code in a minute. But the intent recognition part of these systems are the really cool ones, right? Google has now allows you to basically use their intent recognition system and register an action to do certain things with your app. So if a customer, so if you have a cool, mapping application that maps oceans, let's call it Ocean Mapper or something like that, you can register with Google Now, and a user launches and says, open, my Ocean Mapper application, and it'll do it, right? And you don't have to pay for that. That's already there. That's on all GMS supported devices. I actually did this once with Google Glass. Google Glass does this as well. All right, so I want to talk about Nuance Speech SDK. I don't know a lot of the business arrangements. I was actually fairly surprised that you can get 20K transactions per month, but I don't know which types of speech you get. I don't know if it's just ASR or if you also get intent recognition. A cool piece about it, though, is you can actually upload your own custom vocabularies. A good example is that, let's say that you own Spotify and you want to be able to support when people ask for Eminem. When people ask for M&Ms, you have a higher probability of getting the actual artist M&M than you are getting an M&M by the candy company. But if you get 20,000 transactions per month, that's probably pretty good. Spotify would probably need to pay for it. A little higher version, but that's probably good for most companies. All right. User interface example, we talked about some, how it's a really good way to allow users to basically get through your application, have a good experience, and not necessarily have to click everywhere. So that was a big premise with Glass anyway, where it listens to what you have to say and then it transitions and does things for you. So I wanted to show this. Google released this kind of a really easy way to show flow diagrams, and here's one of them. So the idea is that this is what you see on your screen up in the right-hand corner with Glass. The user says, okay, Glass, then the user in between this arrow and here says, show me the compass. Then the compass recognizes that utterance, transitions, shows the compass. Here's a little bit more involved one with SMS, and I think you guys get the idea. But you also, this is basically a quick reply to an incoming text message. You can just say reply, say whatever it is, and then it sends, right? That's so much quicker than opening my Hangouts app and typing something in and then clicking send and hoping it goes, right? Enough talk. Let me show you some code. You guys all see that? Okay, so this is my phone. And that's my daughter in the background. Isn't she cute? All right, so I'm going to demo something that we're going to do with our application, the company that I work for. The name of it is Driversity. Real quick, high level, we basically take the sensors within your smartphone and we try to understand driver behavior. We spit out certain events based on things that happened. One of the events that we'll spit out is crash detection, right? So the idea is that if you are, use cases, if you're in a car accident, your phone will know about it. And we want to prompt you to see how you're doing. Is everything okay? You know, should we call 911? Should we send a text to your mom? Like, what should we do? So this is not in production. I wrote this for this demo, but it's a good start. Okay, that's a little better. All right, so I've got some developer options in here, so I can just start a trip. Okay. All right. All right. So the idea here is that I'm going to simulate a crash event, and then we're going to pop up a screen, and then the screen will take us through the use case where, let's say you're in a car accident, you can't reach your phone, and we ask the user, we say, you were in a car crash, we noticed this, do you want to take some kind of action? And if you say yes, then we will take an action. In this case, I'm not actually going to do anything, but I'm just going to show the response text in red. Make sense?
A crash event. Would you like to alert emergency services? Yes or no?
Yes. All right, sorry. Yes, I would. All right, so it caught all of that. It actually caught some of the text-to-speech engine. So let me try it one more time. Yes. Money, and it does it, right? So there you go. The yes in the red is basically showing you that it caught yes. So the idea is that you can actually integrate speech engines to do really simple things like understand what a person says. It can say, you know, the grammar or the vocabulary that I'm using is a bunch of synonyms for yes. So you can say absolutely, you can say yes please, yes, all of that kind of thing to be able to understand this. If you're actually going to go to production, what I would recommend is using like a Nuance SDK, upload your own vocabulary and let them actually handle it. Because what I'm doing right now is dictation matching, right, which is not super reliable. I mean, it's actually probably 90% or so, But part of the problem, though, is you don't necessarily know where the phone is in the car at that point, right? They could be right next to the user. It could be far across, on the other side of the car. The Nuance and these other speech providers, probably like IBM Watson, can also tune their model to support microphone locations, right? You don't necessarily do that with standard speech dictation that is available through a platform because it's made for everyone, right? At least on mobile, it's probably made for, you sending a text message, right? You open up your app, you start playing dictation, and you're just speaking standard, sentences to a friend, and you're sending them a message. That's the standard use case. But I wanted to demo this really quick. So there are two different types of speech recognition systems, like I said. Up in the top right-hand corner, you'll see there's a little toggle that says Speech Recognizer. That is what I used. The UI that you saw was just a little progress dialogue that I put in there, a little spinner. And then once we got results back, then it showed the results. And if the results matched, it showed them in red. I'm going to quick show one more. So this is the Speech Recognizer. As soon as the latency of this thing, come on, there you go. All right, so this is the Speech Recognizer. So I'm going to demo this one really quick. So the question that it asks when I get in here is, would you like us to call 911? Absolutely. Well, the speech engine doesn't seem to be working because it doesn't have any RMS feedback. That's lovely. But anyway, so you'll see right here, these are the confidence levels that I talked about, this right here, and of what I said. So this one returned 5 confidence levels, that first utterance. The first utterance was a 90% confidence level of what I actually said, and then it returned 3 others, which it had almost no confidence of. The second utterance that I had, see there are a lot of different options, and clearly the first one was what I was looking for. I wasn't really trying to say that. All right, so let me show you the code real quick for this. All right. So this one right here, get recognizer intent. This is the intent that I'm using to fire off and get that dialogue that pops up, right? Can you not? Let's see. Maybe I can zoom. Command and mouse wheel. Got it. Nope. Okay. All right. So the get recognizer intent, this one actually is what I add to the speech recognizer. So you'll see that I got a reference to a speech recognizer. That's a pretty easy call, just new speech recognizer. You call start listening, and then the get recognizer intent is the parameters. Let's see. All right. So what I can ask for are several different things, right? So this is recognize speech. This is which language. So if you have a device that supports multiple different languages, then you can choose which one you want. There is an API call that you can fire off to say what languages are available, and it'll give you the language codes for it. Then you can pass in your package name if you want. This is actually not a required field. And then you can have a language model. So this one is just free-form dictation. You can also have one that are specific to web searches. So if you have so if you have a text box or an edit text box that a user is trying to do a search in, which is very standard for speech dictation, then you can actually say, I want this to be tuned specifically for searches, web searches. And then you can say whether or not you want partial results, right? Partial results will be, you get part of the word, and then the next part of the word, and the next part of the word. Or you can just say, I want to wait for the whole thing to be done, right? And then just give me the full result. All right. So these right here are the callbacks that happen within the service. So you basically have the on beginning of speech, so you can show something on the screen to say, hey, this is the beginning of your speech. Then there's a on buffer receive, so this is basically an audio buffer. If you want to do something with that, you can. This is on the end of speech, so usually you'll play an ear con at the end of that. Usually you play an ear con beforehand. Then you have the partial results, and so I'm processing partial results, and then full results. And so the full results will replace the entire thing there. The good thing about partial results is that the perceived latency for users is much lower, right? So as you speak, you'll get results faster, but you won't get the full result, right? So if it's a one-shot thing, they basically have to wait till you're done speaking and then return everything. So it could be a 5-minute utterance, right? And you don't get any results. And that seems, most users won't necessarily like that. Okay. The on RMS changed, I mentioned, that is root mean squared. It's a value for basically the amplitude that a user is speaking. So if you speak louder, you can see better visualizations from the device you can provide for your user. In fact, we actually wrote a particle engine for the speech recognition system to show our RMS change values, which is kind of cool. Let's see. Where did I put the other one? All right, so this right here, this method is the first version that I talked about. It is the one that will provide UI in the system for your speech recognition request, okay? So it's like, what, 10 lines, 7 lines, 8 lines, and part of it's my logging. It's more or less from here to here. You create an intent, you pass in this action, you do the same thing with your language models, your freeform, you can talk about the locale, which is EN right now, and then a prompt. So the prompt basically will, say something, whatever it is. In this case, it should say, say yes or no. And then what you do is you do a start activity for results. You fire it off, the dialog pops up, the user says things, the UI is handled by the system, and then the results are returned. Right here, on activity result. You get it back, you pull out your results, your data result, your confidence scores, and then you process it and do stuff with it. So those are the standard speech recognition APIs. There's more, but that's the high-level gist. I think we've got some time for questions. Does anyone have any questions? Gentleman right there. Yeah, so what they do is they have noise canceling microphones. You have noise canceling software. And there's even noise cancellation on the back-end processing as well. All together. Mm-hmm. You were next. So the question was, for simple utterances, can you do that kind of thing on the device as opposed to having to do streaming? There are lots of on-device recognition systems today. Google Glass was one of them. You'll notice that it worked a lot even if you didn't have connection. How I've seen that work in the past is what will usually happen, and Google had this, and they may still have it now. I haven't actually checked, but what will usually happen is that you start speaking and you get results almost immediately, but they're not necessarily as good or accurate as what you would get once you hit the back-end servers with all their power, and then they return the full results that will replace everything in the string. So short answer is yes, absolutely, and you can do it in hardware if you want. Gentleman right there. Yeah. So the answer to that is clearly no. So real quick, his question was that he kind of trolled his friend is probably a good way to put it, where he sent his friend an audio utterance that he played, and then which Google now recognized and then made a phone call. So that actually happens a lot in things like podcasts. Same thing with Siri. I mean, if you have these actions that you say something or anyone says something, and guess what? It just works, then you're going to have that problem unless you handle it a little bit differently. So I'll say the Moto X, I had the first one that came out like 2 years ago, and they had some kind of speaker recognition to actually access the device. So you could lock it, and then I could speak, and it would actually recognize my voice. So I had to train it a little bit. It was really, really cool. But if you don't have those types of checks, then things like that can happen. And I've had lots of podcasts where they talk about some kind of Siri or Google Now feature, and they say, they basically apologize beforehand, like, I'm going to troll everyone who's listening. The lady right here. I have no doubt that would work. I bet you there are a lot of engines that actually do that. That way you don't have to, I don't want to say go pay a licensing fee for the actual lyrics, and I don't know if there is or is not, but it's a quick way to, take a bunch of input and then be able to put that up on your website for lyrics, right? You'd probably have to tune your model for singing as opposed to actual normal speaking, but I would assume that's not too difficult to do. But yeah, I would assume yes. The gentleman all the way in the back. So I'm not a speech scientist. My expectation on how that works is kind of what so the question is that the first step is you get the dictation results, and then you send the results over to the intent engine to then understand and try to disambiguate what the user is saying, right? And his point is that, well, you don't necessarily have tone if you're just returning textual results probably, or JSON results of some sort. And that's a very valid point. I have no doubt that what they probably do, and I'm guessing, is that they have values for tonation. They might even send the audio utterance with it. I don't necessarily know. But I'm sure that's been taken into account to try to get better recognition, and it's a very good point that you brought up. That's the way I would build it. That's what I would say. Gentleman, right there. Mm-hmm. Yeah, so as they tune all of these models, the vocabularies that these models have to take in just get much, much larger. And so, one of our challenges, at least at Amazon, for making sure that we had really good speech recognition was that we had an entire QA team in India, which had a lot different accents than we did in America. So, their results were much worse than ours, right? So we, had to actually make allowances for that. And, we provided feedback to the group that was doing the speech engine, and they worked on that as well. We were targeting a North American launch, and we did it with, US English and Spanish, Latin Spanish. Yeah, so those language models will work differently, but you have to detect those with the engine because you're not going to get a user to say, I have a heavy Texas accent, are you, right? So it's just not going to happen. So all of those things have to be taken into account. And actually what we do, or what we did at Amazon, is we used a website called Mechanical Turk, which is owned by Amazon. And we would, this kind of goes back to the word error rate stuff that I was talking about, where we would have thousands of people who would sit at a computer and record utterances, and then we would have them put in information like I have a Texas accent, or I'm from this area. They wouldn't necessarily say they had a Texas accent, but they would say, I'm from this area, and I'm this many years old. I am male or female between this age and that age, whatever. And we would use that information to build all of our models we wouldn't necessarily, but the group that did it would build the models in the way that would make it much more robust. Yeah, they would read a script, and then they would create the utterances, and actually there would be a second step to that, which is we would have a different group of people go through and listen to what they said, and then they would come up with the truth text. So the actual text, the full punctuation, sentence structure, all that stuff. And we would actually take all that information, and we would, on a daily basis, run thousands of utterances against their production environment and their QA environment and their staging environment. We'd get results. And in fact, we had whole dashboards and everything that would say how they were doing. So if they made a change and suddenly our word error rate went up, then we would get alarms, and we're like, excuse me, things are down. And it's kind of interesting. The group that was doing this for us actually asked for access to our dashboards because we knew when they were down before they did, which was freaking awesome, not gonna lie. All right, cool. Anyone else? Gentleman in the back. Mm-hmm. So I don't work for Google. I don't work for Google Now, and I never have. But according to their documentation on their Google Now on Tap page, it works for any app. So that tells me that they figured out ways to crawl all of those apps and figure out information. Now, there's a search API within Android as well, where you basically say, I'm a searchable app. I want you to be able to search me outside of my process, and so you have to register for it, and then you can upload your collection, more or less, your searchable collection. There may be APIs that allow better integration with Google Now on Tap. I would assume they would try to do something like that, but it sounds like they're at least selling that it should work with any app. I don't know if I'm buying yet, but that's still really cool, right? At least I think so. At I/O. It might be a Marshmallow thing. It might not be. I mean, considering it is. Okay. Well, it's a software thing, so that's why I'm thinking it might be something else, because Google Now is an app, right? You can do updates to apps. It's kind of the way Google's been moving, especially with like Google services, Google Play services, and having a lot of the really good things like cloud messaging within services, trying to make people be GMS compliant. Any other questions? All right, I have one more thing I just want to show real quick. All right. So Nate and myself and Antonio and a few other people are, trying to start up this Android meetup group. I highly encourage all of you to join, participate. If you want to speak, let us know. We really, really want to make this about the developer and the designer. If you have good ideas, just shoot us an email, and if you want me to talk about it or Nate to talk about it, we can do that too. We highly encourage all of you to come, and happy hacking. Stay here. Okay. Yes. All of that stuff right there. Everyone, honestly. Like well.
Anybody who wants to develop, basically. If you're interested in designing for Android, developing for Android, starting a business that serves the Android terms, all of it.
Yeah. And if you're an iOS developer and will come over to the dark side, we're all for it.
We're not after enthusiasts. That's the thing. We're really after people who want to talk and work with the technology.
Well, we want enthusiasm, right? So I'm all about enthusiasm. We're gonna have lots of fun things. We're open to suggestion. I love hackathons. I was part of the Lab 126 evangelist group at Amazon, and I talked leadership into giving away $12,000 in devices. We don't have that kind of money yet, but hopefully, if you guys make us big, I can go talk to people like Samsung and get them to sponsor us and give away good stuff. So that's kind of a little spiel on that. Come join us. We're lots of fun. And we have a happy hour, I think, October 8th, yes. We'd love to see all of you down there. Cool? All right, thank you very much.